हॅलो सर.
हा बोला ना. हा
सर हर्षदा आष्टेकर बोलते. मी नंबर टाकलेला आहे पण ते तुम्हाला नेम दिसतोय.
अच्छा, I don't know what is the problem with this. Anyway, we'll sort out this issue. Okay, let us say now you please close your microphones. म्हणजे mute करा. I will start with this particular topic. This is the most important topic, that is history of Intel processors. So you know the importance of processor and what is basically a microprocessor. So we say microprocessor is a single chip on a CPU on a single chip. That is normally called as a microprocessor. That is the definition of microprocessor. And if you see this microprocessor leading, this is pioneer of microprocessor is Intel. In fact, this is a leading manufacturer and there is no competitor as such to the Intel as far as processors, processor quality, inventions, and maybe the future upgradations. If you see, in entire 90% of the entire world market is captured by Intel processors, and hardly 10%, maybe 5-7%, maybe the AMD processor, that is advanced micro devices processors, and remaining 4-5% are Cyrix and some other processors are in the market. But leading processor is this, and it is not from now, as we have to see the history of these Intel processors. So here in this history, it is first processor that is started somewhere in 1971. So in today's lecture, I was supposed to complete up to Pentium processor and then Pentium 2 to 49 processor we may see tomorrow. Let's see how much time we get and accordingly we'll finish up to Pentium processors. So when you talk about processors, I believe you have a certain concepts of processor in mind. I mean, whenever you talk about the processor, you always know what is address bus, data bus, control bus, maybe CPU or maybe ALU, then flag registers, say maybe core segment registers, queues, then execution unit, bus interface units, how this data is moved from one, then maybe instruction cycles, then execution, decoding of instruction, all this. This is the basic concept of for any microprocessor. Now, if you start some microprocessors history or importance about any microprocessor, so you should know what is the name of a microprocessor, maybe in history, where at which year this processor is developed, then maybe number of transistors were present on each CPU. Then what is the data width or what is the number of bits that can be processed by ALU at one time, that decides the data bus width or maybe bus width of that processor. It may be from 8 to almost 64 bit. And what other important is what is the speed of processor, that is how much clock, what is the clock frequency, and more the clock frequency, obviously the higher will be the speed of processor. These are 3 slides. Later on you can go through these particular slides. Details of these slides I am going to explain from this particular slide. As this indicates, somewhere Intel started first microprocessor introduced in 1971. Please mute your microphone. So here this microprocessor, first microprocessor developed in 1971. The name given by this Intel is 4004. Reason behind this is that it was a 4-bit microprocessor and it has having a memory of 4 kilobytes main memory. If you see the chip of this chip shows it is something like a 16-pin chip. If you see the package, that is dual inline package, and it is developed from a technology that is called as a PMOS technology, that you know, positive channel metal oxide semiconductor. These are the technology that is used for fabrication of this particular CPU. This CPU has got it is having about 23 transistors, and obviously it has the CPU. But when you talk about the 4-bit processor, that means only 4 bits can be processed. That is ALU of only 4-bit. Immediately after, in 1 year, another processor in between They have also developed 4040, which was the extension of 4004. After 1 year, in 1972, this 8008 is developed, and this is compare with the 4004. It is 8-bit microprocessor, and memory is increased from 4 kilobytes to 16 kilobytes. Almost it is having 48 instructions. When it comes to one here, instead of 16, it was a 19-pin chip. So you can see the structure of this particular uh, IC or 808 microprocessor, but it was again a relatively a slower processor. After this 8008, immediately first professional, or you can say general purpose microprocessor developed was 8080. Immediately after a 1 year, that is in 1973, it is developed. It is 8-bit microprocessor. It has a capability of 64 kilobytes of main memory it can address. Now, incidentally, it is the basic, or it is a conventional memory that is normally available onto your computers. So here, when you say 64 kilobytes of main memory, then see, I have shown you on right hand side that is a one kit, 8080 kit. And in fact, this is a one microprocessor development kit. On this particular kit, the processor is the 8080 with certain interfacing like clock or some chips. There may be ROM chips for coding the instruction, certain IO sockets, then a keyboard controller, and certain, say, you can have you can directly program by using this interface of keyboard controller. So somebody has kept microphone on, that is disturbing me, or maybe you. Please see to your microphone is off. Then see, at that time,
लेक्चर चालू.
हा कोणाचा तरी आवाज येतोय मला तुमच्या घरातनं. कोणाचा तरी मायक्रोफोन चालू आहे. Okay, let us say now when as I said, it is relatively faster than 8008, can handle 50,000 of instructions per second. Now it is improved version, that means it was using negative channel metals oxide semiconductor technology, that is NMOS, which is better than PMOS technology. Then it is considered as a first general purpose microprocessor. Then most of this microprocessor was requiring a 3-pin power supply. Now another development into 8080, it was working about 5 megahertz speed. Then improved version is 8080A, which is requiring only a single voltage supply. So now this kit may be somewhere in, I will say, 1985-86. At that time, whenever students were studying microprocessor, either they were using 8080 or they are using 8085 processor. At that time, this is a practical kit, which you are familiar. Probably you have done some practicals on a microcontroller kit. This microcontroller kit or 8085 practical kits or experimental kit is very similar. Now, in fact, if you see the study of microprocessors and whatever I said, the basic concepts in a microprocessor, that is bus concept, ALU concept, interface concept, instruction decoding, this is largely available, or most of the basic concepts are available in 8085. So if you see the books on microprocessor, a lot of books you will find on 8085, because that was the basic microprocessor studied in college days, or even in engineering, or even in diploma level. So these kits were available, and this is mostly studied academically. Even today also, in most of the colleges, students do study 8085 microprocessor. Now, if you so this was the first processor developed in 76, required only one positive volt power supply. Then it is 8-bit microprocessor. If you see, this is again a 40-pin dual inline package socket. This is working about again 5 megahertz, and most of the interfacing it is possible, or even 8085 can be used for doing many control application, even for interfacing between computers and kits or a serial communication. This type of control circuits, which is normally used even in industries also, this 8085 was also popular and it was used for basic control circuits. After this Intel 8085, this was the processor which became popular mostly in industry. Even academicians also studied this 8086 and 8085. It is developed 2 years later, somewhere in 1978. As I said, it is the industry standard. This is 16-bit microprocessor. When you say 16-bit, obviously ALU can perform the instructions, or ALU can take a data 16 bits simultaneously, and it can do add, subtract, multiply. These similar operations can be done simultaneously on 16-bit data. That is why, as the data bus width is 16-bit, hence it is called as a 16-bit microprocessor. Another important feature is that it can address up to 1 MB memory against earlier microprocessor. When you say 1 MB memory, as you know, if you have a 16 address lines, you can at the most you can address a memory of 64 kilobytes. When you say 1 MB memory, to address 1 MB memory, you require additional 4 lines. That means 16 plus 4, it will give 20 address line. And if you have a 20 address line, that is 2 raised to 20, then that will give you what is called as a 1 MB memory. As you are familiar, 2 raised to 10, that means if there are 10 address lines, you can address 1 KB of memory. Okay, if you have 11 address line, you can have 2 KB of memory. 12 address lines, 4K of memory. Like 16 address lines, it will go to 64 kilobytes of memory. If you go on adding this, that means 17 will go for maybe 128 kilobytes of memory. If you have 18 address lines, it will go to 256. For 19 lines, it will go to 512 kilobytes. If you have a 20 address lines, then it will go to 1 MB of main memory. So you know the relation between address lines and the maximum memory that it can address. As you know, any memory, it is actually you address the byte. Every byte is addressable. I mean, every byte has a unique digital address, and that address will be a 20 bits address. As I said, this also has a 16-bit data bus width. It was very popular in this, and if you see right side, the structure of microprocessor, then here you will find basic concepts are there. ALU, operand, flags, maybe general purpose register, the AX, BX, CX, these are 16-bit register. Then stack segment, base segment, segment instruction register. Like you have a certain segments and instruction pointers, etc. Then accordingly you have a execution in it as well as bus interface unit, and here the concept of prefetch queue, that is queue concept, that is when one instruction is being executed, already one next instruction is already fetched in a queue. This particular concept was developed in 8086. Then after 8086, Intel developed this 8088 processor, and in fact from this 8084, whenever we say that IBM launched its PC, and in fact this IBM first processor that is used in IBM PC was 8088. So this was developed in somewhere in 1984-85. These IBM PCs were very popular, and in fact in all the college days, even when I joined somewhere in 1990 in government polytechnic, and from 1992-93 onwards, I have used this particular IBM PC having processor as 5 megahertz. Maybe hard disk is hardly of a this is of hardly 5 MB hard disk was there, very big size, and this is 8088 processor. If you see this is on right hand side, you will see the motherboard of that particular 8088 CPU. At the same time, you will find lots. These are the ether slots are there, that is the old slots. Then if you see on a right hand side, you will find this is the bank. This is all the memory banks, and at that time memory was very costly. So that is why that was a limited memory onto your computers. Normally 640 kilobytes normally was there on a hard motherboard, and this is a fixed memory soldered onto your this you can see these are DIP packages which are actually fitted onto your motherboard. But anyway, this was the first processor which was capable of it was working on what operating system, something like a DOS or disk operating system, maybe version up to 1 to 2.3, 3.0. That operating system version was there, and you used to do a simple programming like basic Fortran, COBOL, those type of operation, or simple word processing. That type of applications was possible on this particular processor using 8088. Then after that, between 8088 and 80286, another processor launched by Intel was 80186. It was not basically included here because 80186 largely for catering the needs of industry. If you see 80186 is the architecture which falls under the category of microcontroller. So at this stage, you know the difference between microprocessor and microcontroller. Normally, microprocessors are used in a computers, maybe for computing purpose. Then on the other side, if you see microcontrollers, these are used for some dedicated applications. As you studied, maybe in robotics or embedded system, or to run certain typical device, or maybe if you want to run maybe your fridge or washing machine. In that case, you don't need a microprocessor. For that, you need certain all aspects of a processor which is built inside a chip. That is what we said, something like you need a CPU, but at the same time you also need a peripherals. You need a RAM and IO. So all these for this IO and all this, another chip that was developed is microcontroller. So this is the 80186. Then after this 80186, the next processor launched by Intel is 80286. Again, like 80286 also we received somewhere in 1992 in government polytechnics. And I worked on these also. The speed was about 20 to 25 megahertz. Then the RAM memory was about 1 MB memory was there for this. 1 MB, 2 maybe. Maximum memory that can address was 16 MB. But as the memory was very costly, so even if you get a 1 MB memory, that was much more memory for executing most of the softwares available at that time. So this is basically a 16-bit microprocessor, and it has got a memory management and protection. So this CPU are allowed to work in real mode or in protection mode. Then instruction execution time was very much reduced because clock speed is increased, and at the same time it is working with the 16-bit microprocessor. It has got a very good features, something like memory management. So memory was effectively used because earlier computers used to work with only 64 kilobytes conventional memory. If you have an upper memory that is higher than 64 kilobytes, then how it should be used? Then there were certain softwares or memory management was better, and it was being implemented in the respective operating system like DOS 5 or DOS 6.6 or 6.0. Like those were the versions which were using this memory effectively. Then the concept of pipelining was also introduced in 8086, 80286. Now you know the concept of pipelining. Then multitasking, that means not only one task, but you can have a multiple tasks simultaneously, and you can switch between the tasks, as we say in a taskbar. At that time, again, there was no graphical system, but even though not the graphical system, but it was capable of handling multiple tasks simultaneously. Then if you see the difference between structure of CPU, you will find here there are 68 pins for this CPU. There is no leads like DIP pins. In fact, it was packed in a one package that is called as a PGA package, pin grid array. which is having 68 pin. At the below here, this particular package is shown, which you can directly insert in a PGA socket. So automatically these connections will be made. If you see again, this is somewhat advanced structure inside structure. As the number of transistors are increased, capacity is increased, 16-bit registered, so ALU is somewhat powerful. Then its execution unit is same, address unit it is now capable of. When you say 16 MB memory, so obviously you need to have 24 lines to need this particular 24 address lines. So that is why you said A0 to A23 lines are there here on right hand side. These are the address pins. Data pins are also D0 to D15. Otherwise prefetcher, or if you see each and every control say block, hopefully you now are aware about the functions of each block. Then after this 80286, the new processor came into market, and this was nothing but the 80386 processor. In fact, I remember that somewhere in 1994, I purchased this particular first PC for my own work. At that time, I was doing my ME work, and that ME I was doing certain graphics in C. So to work that particular, I have purchased this, and it was costing something 26,000 with black and white monitor and VGA. The graphics is there, and it was having a processor Intel DX2, that is 386DX. That is the name was given to this. And if you see the this package is now changed. So this is 132 pin PGA package. So here again this is, as this is a processor which has to be just this particular socket, as you see, it is a ZIF socket, that is zero insertion 4 socket. You just have to place that CPU above this, and you have to pack that CPU. The lighter version of this S was come with what is called as a i386SX. It was also having a 16-bit data bus. If you see some of the good features of it, it is the first 32-bit microprocessor, and also called as i386 or 386. So it has got 32-bit data bus, as well as it has got what you say, this is a 32-bit address bus. So when you have a 32-bit address, then it will address up to 4 GB RAM. But data bus is only, it is of a 16-bit, and it can also be changed to, later on it was changed to 32-bit bus. Okay, so here basic SX is with 16-bit data bus, but when you say DX, that is why name the given as SX and DX. That is, DX is double the amount of data bus, that is 32-bit. And if you have a 32-bit address, you know that the maximum memory, that is 2 raised to 32, you can now address in the range of GB. That is the maximum memory that you can fit in a motherboard having DX2 processor. It will address up to 4 GB RAM. This was the first 80386 developed, that is PC developed by Compaq using 80386, and its speed was almost up to 12 megahertz to 40 megahertz, but it was giving a very good performance. As far as mostly we used to work mostly on a text or a maybe programming languages, or mostly very, of course we will work with the graphics, but very limited graphics. Then these are the some, as we covered this particular features of 80386, 32-bit, somewhere 8586 launch, maximum frequency 30 to 43. Then almost 2,75,000 transistors were on chip. The size is now reduced to what we call as an in micrometer, 1.5 micrometer size per transistor. Address up to 4 GB. Paging was introduced. This is the concept of paging, means here the memory was limited. Okay, even it can address up to what we can say it, even if you have a 4 MB of memory, then in that case, if you want to manage that 4 MB of memory or 1 MB of memory, this entire memory is divided into pages. Then whatever the CPU demands, if that is available from the memory, then that is given to the CPU. If that data is not available in a certain pages, then what is done that this instruction or data is fetched from your hard disk and put it into that particular page. The page size is normally 4K, 8K, 32K. Okay, accordingly, that entire data is swapped between RAM to hard disk or hard disk to RAM, and that data was made available. Why this is required? Because some of the programs require a larger memory. To fulfill that particular requirement, the concept of paging was introduced. And accordingly, paging has got a different algorithms, that is first in, first out, or a last in, first out. That is a page which is to be swapped or removed from the memory. Or you can have a least recently used or recently used. The page which is not used, probably that is not likely to be used again. So that page was to be swapped out and another page was taken into a memory from hard disk. That is the concept of what we call as an paging. In fact, this was the best selling microprocessor somewhere in 92 93, and mostly most of the requirements and most of the softwares like what you say Microsoft Office, or at that time it was actually the Word was popular, Lotus was popular for calculations purpose. What you say Excel, it was renamed earlier, it was used as a Lotus or a Microsoft Word, or these are some software, some DTP softwares were there and which were popular for 80386 in somewhere in 92 to 95. Now we'll consider this as the last CPU and then we'll stop here so that from next lecture onwards we can start freshly with the Pentium processor. In fact, this is the 80486 processor. It is the last processor in the 80 series, launched somewhere in 1989. It is 32-bit microprocessor, just like 386. It is 4 GB memory it can access, but its execution speed was almost 40 million instructions per second. So this is relatively a very fast CPU. The concept of cache memory was introduced in 80486 CPU. So 8K cache was there on your CPU itself. That is what we have studied cache. So you can say L1 memory of 8K was there on your CPU package itself. It was also using the concept of pipelining. Instruction get executed in a one clock rather than the two clock used in a 386. So obviously the speed is drastically increased. Number of pins from 132 it is increased to 168 pin. Again, this is pin grid array package. So this is a 486 processor. Now if you see, this is a motherboard now of a motherboard which is using CPU as 80486. Now I think if you see this CPU now or some motherboard, you can understand now because most of the things we have already studied now. So if I'll say on left, we'll start with this keyboard socket. That is a DIN keyboard socket. Next time probably after this lecture we may go for keyboard and mouse, all this. So this is a DIN socket that is used for this keyboard. Then this is a clock battery, which is somewhat different than what we used to in a CMOS battery. Then you can see we have studied something like what is 8-bit ESA bus. So this is small bus which we have already studied. Then if you see there are 5 slots, which is consist of 16-bit ESA slots. Then you have a chip, separate chip, that is keyboard controller 8279. Nowadays we don't have in our next chips. We'll find that this is this is keyboard controller is now included in your chipsets. You can also see there are 2 chipsets. One closer to this is North Beach Opti chipsets, and this is small. This is catering the need of what we call as this IO peripherals. This is taken care by this Opti chipset. Then this is onboard cache. That is the L2 cache. This is here if you find this. Then this is a BIOS which we are going to study, EMI BIOS, where you can set the settings of motherboard and the configuration of the motherboard, and during runtime you can have this. This is particular power socket, that is 20 pin power socket, which actually power supply is given motherboard through this particular socket. And you will find these are the RAM chips, DRAM chips. So these are the two different slots, and if you see, these are the something like these. You can have 1, 2, 3, 4 slots are provided. Either you can use these two slots, or you can use either these two slots. So these are the memories provided. So as we have studied in detail, so I don't think we need to go details about this. But when you talk about 80486 architecture, in this architecture, what is the difference compared to earlier? You will find that there is a floating point arithmetics. In fact, floating point arithmetics was introduced in right from 2088 to 2087 was this microprocessor. But when you talk about the 86 processor, 80286, then you have a math processor that is 2080287. Similarly, 3086 processor, you have math processor 30387. For this also 80486 is the processor, and to help use for floating point arithmetic, it has got a supported math coprocessor, because some, yeah, actually you know why you would need a floating point, mostly for graphics and some uh, calculations with high precision or high accuracy. In that you need a floating point calculation, so that math processors are used. You see the bus is of 32-bit bus. Then these are all what you can find. This is ALU. Now after this, the basic structure, if you see, the cache was here, the cache control, cache memory was here, paging unit was here. Then this is what we called as an how to access this and how to use effectively memory, how this memory is to be divided by the segmentation. Ultimately, all this data was brought down to your ALU process this particular data and then give it to the memory. Then this is the memory, how this memory can be managed. Everything memory as well as address bus was of 32 bus. And if you see this bus interface, this is for external world. That is how this data can be transferred from your CPU to the external. Maybe here this address drivers are there, data bus transceivers. If you want to transfer the data out of CPU or take inside the CPU, this is there. Then this is a queue register, and this is instruction decoding, and this is a control and protection circuit which takes care of your execution of your instruction. So this is the somewhat a complex architecture, but remember 80486 was a very good processor, very powerful processor, and in fact it was very popularly used till 2000. Then somewhere in 2000, after this 80486, this scheme of naming stopped. In fact, uh, Intel cannot continue with the 80586. In fact, instead of giving the name as 80586, because before Intel giving the name as 8056, AMD and some other devices came into the market with the processor having 8056 as architecture. And this has decrease. In fact, that's uh, due to this, the market of this Intel was affected, and there were also certain problems, legal problems as well as brand problems. So hence, from this 80486, Intel discontinued its 86 processor names, and from that onwards, they came up for their brand names and from copy issues. So what we say intellectual rights and copy issues. To overcome these particular issues, they come up with the processor and they have given the name Pentium. That is, this was the fifth architecture, and Pentium means 5. That is, in fact, that is why they have given the name this particular processor as a Pentium processor, and they came into the market with Pentium processor, which is much 5 times faster than your 804X processor. So this is all about some half information about development of Intel 80 Intel families. Probably this is just for a history purpose and just to have some idea that how Intel has been developed or over the age, how this microprocessor has developed right from 4004 to 80486, and how these concepts are slowly grown and matured, and this is developed into a good and faster process. So every time you will find the address bus is with memory address is increased, data bus is increased, clock bus is increased, some of the additional facilities are implemented into your CPUs. So this is all about I want to take today this about this lecture. From next lecture onwards, we'll start with the Pentium as such. And as usual, if you have got any difficulties now, you can ask me the difficulties. So go ahead if you have got any difficulties. Have you understood now? Hello, can you hear
Hello.
me?
Sir, can you explain again the paging concept?
पेजिंग कन्सेप्ट
Yes.
म्हणजे काय असतं? पेज म्हणजे थोडक्यात एक साधा आपलं पुस्तकाचं पेज घ्या असं विचार करू आपण की आपलं पुस्तक आहे आणि पुस्तकातलं काय जे लागतं ते आपल्याला आपण काय करतो ते पुस्तक उघडतो पेज आणि आपण बाहेर काढतो आणि वाचतो. बरोबर आहे. आता असं विचार करू की ते पुस्तक आपलं हार्ड डिस्क मध्ये आहे असं ऑर्गनाइज केलेलं. आता सगळं पुस्तक आपल्याला मेमरीमध्ये घेता येईल का? नाही घेता येणार. बरोबर आहे ना. मग सीपीयू ला जे काही लागेल ते त्याने हार्ड डिस्क मधनं काढून तुला मेमरीमध्ये आणावं लागेल ना. मग त्याच्यासाठी काय लिमिटेड पेजेस असतील. इथं एक 15 समजा 20 पेजेस आहेत. त्या 20 पेजेस मधलं जर 21वं पेज आणायचं असेल तर कोणतं तरी पेज बाहेर काढावं लागेल आणि दुसरं पेज आत मेमरीमध्ये घ्यावं लागेल. बरोबर आहे.
Yes.
म्हणजे जो काही डेटा असेल तो हार्ड डिस्क मधनं काढून मेमरीमध्ये आणावा लागेल. आपण त्या मेमरी मधलं जे अगोदरचं आहे ते मग कोणतं काढायचं? जे आतापर्यंत उपयोग झाला नाही, जे लिस्ट रिसेंटली यूज असेल, त्याचे कदाचित थोडं फ्युचर मध्ये गरज पडणार नाही, असं त्याला परत हार्ड डिस्क ते बाहेर काढायचं आणि त्याच्याऐवजी ते लोड करायचं. त्याला या कन्सेप्टला म्हणतो आपण पेजिंग कन्सेप्ट. ठीक आहे.
Okay, sir. हो.
अजून See, about 32-33 hours there. मला हे कळत नाहीये अर्जुन किंवा साक्षी प्राची काय असतील तुम्ही. Why the attendance of the class is so poor? ते हा एक मला प्रश्न आहे. त्याच्यामुळे मला आहे ना ते तुमचे एनरोलमेंट नंबर्स आहेत ना, मला एनरोलमेंट नंबर्स वरती फार महत्वाचं आहे. अननोन युजर्स मला अजून कळत नाही हे लोक का जॉईन होता अननोन युजर्सनी, पण माझ्या दृष्टीने ते ऍबसेंट आहेत हे मी तुम्हाला सांगतो. आणि मग बाकीचे जे लोक आहेत त्यांना सोडून मी बाकी सगळ्यांच्या पॅरेंट्सला कॉन्टॅक्ट करणार आहे. ओके. आता इथे मला जे दिसत आहेत तेवढे मी सोडून देतो, एवढे जे नंबर्स आहेत ते. and from today onwards I am going to be serious about the lectures or their attendance. कारण मला हे समजत नाही की even I don't know what is the attendance for other lectures and this. पण मला त्याची फारसं हे नाहीये. That's because we are going online. We expect all you to be online. जरी आता नसला तुम्ही तरी तुम्हाला माहिती की तुमचं लेक्चर्स मी तुम्हाला ऑफलाईन अवेलेबल असणार आहे ऍज इट इज जे रेकॉर्डेड आहे ते. ओके. सो हिअर जस्ट तुम्हाला काही क्वेश्चन आहे कोणाला? सो अदरवाइज वी कॅन स्टॉप दिस रेकॉर्डिंग.
सर ते फ्लोटिंग पॉइंट बद्दल थोडं हे इन्फॉर्मेशन पाहिजे होते सर. म्हणजे तो कन्सेप्ट कळाला नाही.
अच्छा.